looking at a pedigree, how do we figure out whether it's 1A, 1B, or 2? And all we do is examine the patterns of shading. Now you guys know what it means, God bless you. You guys know what it means to be dominant and recessive at this point, right? Yeah. If you're dominant, what do you have to have? All right, so if you have that version of the allele, that's the phenotype we see, no matter what else is present, right? You only need one copy. If you're recessive, what do you need? So you need 2 copies of that particular allele. God bless you. Bless you. If I were looking at a pedigree for an autosomal dominant trait, so if I were examining a pedigree for an autosomal dominant trait, it's going to occur equally as often in males versus females. So if you're counting circles versus squares, it'll be roughly 50-50. So first thing you look for, it's going to be 50-50 male versus female. The second thing we notice, if a parent has the trait, if a parent or 2 parents have the trait, their offspring will have the trait. So if the parent is dominant, the offspring will be dominant. Now, so will most offspring, right? Doesn't have to be all of them, because what could those parents be? They could be heterozygotes, right? They could have 1 dominant, 1 recessive. Most of the time. Mostly. Not always. When one parent is affected, so when one parent has the trait and the other does not, half of their offspring will have it. So if you see someone who is shaded in and their spouse is not shaded, half of their offspring will have it. It does not skip generations. So if someone in generation Roman numeral 1 has it, if it's dominant, someone in generation Roman numeral 2 will have it. Someone in generation Roman numeral 3 will have it. You won't go, it occurs in 1 and 3, but not 2. So it does not skip generations. And the last thing, unaffected parents do not pass on the trait. Unaffected parents do not pass on the trait. So if mom and dad aren't shaded, there is no way child will be shaded. If this is true for autosomal dominant, what do you think is true for autosomal recessive? Well, for point number 1, what was point number 1 on autosomal dominant? 50-50. Same thing is true for autosomal recessive. 50-50, females are affected or unaffected equally. So males and females, equal frequency. However, when we look at recessive things, they can skip generations. If it is recessive, the trait can skip a generation. If two parents possess the trait, but they're heterozygotes, only 1/4 of their children will possess the trait. So if two parents have it, but they're heterozygotes, only 1/4 of their children will have it. And the last thing doesn't occur on every pedigree, so it's hard to use it as an example. When there are consanguineous relationships, it occurs more frequently. What's consanguineous mean again? Within blood, right? Inbreeding. So when there's inbreeding, you see it more often. And then today's Bell question asked you about sex-linked traits on a pedigree, and what I saw some of you draw on there. Yep. Have it. Children have it. There you go. So if autosomal things are 50-50, boys and girls, sex-linked things, who has it more often, boys or girls?
Boys.
More often in males than in females. It will not skip generations. So if it is X-linked dominant, it will not skip generations. Now it is possible to have X-linked recessive, and those can skip generations. But if it's X-linked dominant, it does not skip generations. Affected sons must have a carrier for a mother or an affected mother. So if a boy has it, his mom was either a carrier or she has the trait. Affected fathers will pass it on to all of his daughters. So if a son has it, mom has it, or is a carrier. If a daughter has it, dad absolutely had to have had it. Make sense? Okay.
So moms pass it on to the sons and the dads